Part 3. OK, so let's move on to look at some of the applications of signal processing and filters. There are so many applications that it's actually been quite difficult to choose just one of them. But I've chosen what I consider to be one of the most important. In fact, as Ansari and Valbanese point out, in the Electrical Engineering Handbook, which is one of your core texts, the first edition was published in 2004, signal processing is everywhere in everyday life, although this may not be evident to most people. Anyway, today I'm going to focus on active noise control, or ANC. This is an extremely important application of signal processing, both analog and digital, and has resulted in some very useful devices, as we shall see. We use the term active because there are also passive methods of controlling or reducing noise which you may be familiar with. Earplugs, for instance, or soundproofing using sound-absorbing ceiling tiles. We call these passive because there is no added power to the noise control system. One definition of active noise control, given by thefreedictionary.com on the web, is a method of reducing unwanted sound. So ANC is basically a way of taking an unwanted audio signal and eliminating it, or at least greatly reducing it. Let's first look at what sound is exactly. Well, as you probably already know, sound is a pressure wave. It consists of two phases, a compression phase and a rarefaction phase. Please note that while rarefaction begins with the spelling R-A-R-E, the E is pronounced as a separate syllable. So we say rarefaction. I'll just write that on the board for you. In ANC, a computer analyzes the waveform of the incoming unwanted sound and then generates and emits via a speaker a sound wave which is identical or directly proportional to the original audio signal in terms of amplitude. However, the wave has an inverted phase compared to the original wave. This means that it is 180 degrees out of phase with the wave associated with the noise. We also call this antiphase. This means that the two waves combine and form a new wave. We call this process interference. The waves basically cancel each other out. This destructive interference is known as phase cancellation and results in an output signal which has such a small amplitude that it may not be audible. There are three basic models of ANC, and in each one the speaker, or sound or wave transmitter, is placed in a different location. In one model, the speaker is located next to the source of the unwanted sound. It follows from this that the speaker must emit its cancellation signal at the same power level as the source, probably quite a high level. In another model, the speaker is located where the sound reduction is required, and that means near the listener's ear. Of course, in this case, we can use a much lower power level. However, it does mean that each listener needs his or her own speaker, so the situation becomes a little more complicated in that sense. Sometimes the speaker is put in a third position, neither at the source nor at the ear. However, this can work only with a stationary listener, because as soon as he or she moves, the sound and cancellation signals will no longer match, and the interference will no longer be effective. By the way, I see that some of you are using the Cornell note-taking system. That's very good. Do you all know about this? No? Right, well, if you want to know more about it, I suggest you look at How to Study in College by Walter Pork, the 10th edition, published in 2010. It's very good, and it should be in the university library. I'm sure that you all know the importance of taking good notes, and this system is particularly useful. So, to get back to the main topic, as you can imagine, active noise control works much better than passive methods. This is particularly true at low frequencies, for which passive soundproofing is less successful. ANC also works best when the sound is periodic. Don't forget that when we use periodic in electrical engineering, we mean repetitive. This is different from the general English meaning of periodic to mean something that happens not very often. And the fact that ANC works well with periodic signals holds true even if the signal is quite complex. It also follows from this that random sounds, by which I mean non-periodic sounds, create more of a problem in terms of cancellation. Let's now look at a specific application of ANC, noise-cancelling headphones. These consist of a pair of headphones which completely cover the ears and form a physical barrier that can help block high-frequency sound waves. They therefore use classic passive noise cancellation methods. But they combine these with active methods too, and it's this concept that interests us today. A microphone inside the headphone cup picks up the external sounds that cannot be blocked passively. An electronic device, located next to the microphone, analyzes the amplitude and frequency of the external sound signal to generate a new wave in antiphase to the original. Circuitry feeds this new wave into a speaker located in the headphones, and destructive interference erases the noise. All this is powered by a rechargeable battery. The great thing about these headphones is that ANC can be used in parallel with a normal audio signal coming through the speaker, such as when we are listening to the radio or watching a video. The speaker simply emits the anti-sound wave created by the ANC device together with the normal audio, and the result can be surprisingly effective, providing a reduction of up to 20 decibels in addition to the passive noise control that the headphones provide. Now, I think that's all I'm going to say for the moment on ANC. Are there any questions so far? No? Okay. Now, when I see you in tutorials, we'll look at how digital signal processing developed in the 1960s and 1970s, and the inventions that helped this development take place. In the meantime, I'm going to set you a research task. Now, as I said before, it's easy to forget just how many applications of signal processing there are. To quote Ansari and Valbanese, users may be familiar with JPEG, MPEG and MP3 without recognizing that these tools are rooted in signal processing. Right, now listen carefully. Your research task is to find out about one important application of signal processing in more detail: speech recognition, otherwise known as voice recognition. Now, there are several different systems included under the general term of speech recognition. I'd like you to work in groups of 4. I want each group to find out about one speech recognition system and report back on their